Hi, and welcome to my presentation on atomic structure and bonding. In this presentation, I'll be looking at understanding ions, their bonds, and the polymers, and following these learning outcomes. First, I'll look at atmospheric ions and ionic bonds from scenario 3. Ions are charged particles that form when atoms lose or gain electrons. They are electrically neutral because they contain equal numbers of protons, which are positively charged, and electrons, which are negatively charged. However, when an atom loses or gains electrons, they form ions, which are charged particles. Ion formation depends on the number of valence electrons and to the atom's tendency to have a stable electron configuration, often resembled by noble gases, which have a full outer shell of electrons. Cations are positively charged ions which are formed when an atom loses electrons, meaning they have more protons than electrons. Anions are negatively charged ions and are formed when an atom gains electrons, meaning they have more electrons than protons. All metals lose electrons to other atoms to become positively charged, whereas all non-metals gain electrons from other atoms to become negatively charged. Atoms consist of a nucleus, which contains protons and neutrons, and has electron shells surrounding it. Electrons occupy specific energy levels with the outermost shell containing valence electrons, and these valence electrons determine how atoms interact and bond. Elements in group 1 of the periodic table have one valence electron, making them highly reactive, whereas group 8, which are noble gases, have full outer shells, making them stable. Scenario 3 states that ions form when neutral molecules or atoms in the atmosphere undergo ionization. This ionization is caused by ultraviolet radiation from the sun in their upper layers, or radioactive radiation and cosmic rays in the lower layers. These knock electrons out of atoms, creating ions in the atmosphere, such as cosmic rays ionizing oxygen molecules to form O2+. These energy sources knock electrons off neutral atoms or molecules, creating positive ions and free electrons. These free electrons can then attach to other neutral atoms to form negative ions. Atoms gain or lose electrons to achieve a stable configuration. Sodium will lose one electron to form Na+, and chlorine gains one electron from sodium to form chlorine-. Scenario 3 also mentions that atmospheric ions instantaneously combine to form molecules with ionic bonds, due to a strong electrostatic attraction. In terms of this electrostatic structure, one atom, typically a metal, loses electrons to become a positively charged ion, and another atom, typically a non-metal, gains an electron to become a negatively charged ion. The resultant ions are then held together by their opposite charges. Ionic bonds will form between oppositely charged ions, such as a cation and an anion. The nature of this ionic bond is strong electrostatic attraction between the positive and negative charges, and these oppositely charged ions form ionic compounds such as sodium chloride. And these ionic bonds complete the outer electron shells of both atoms, making them chemically stable. I will now look at covalent bonds in polymers for scenario 4. Scenario 4 mentions that polymers have a molecular structure comprising of a large number of identical molecules covalently bonded together to form a long chain structure. These covalent bonds form when atoms share one or more pairs of electrons in order to achieve a stable electron configuration, such as a full valence or outer shell like a noble gas. This sharing of electrons creates an overlap of the electron clouds of the bonded atoms, making an attractive force that holds the atoms together. Covalent bonds typically occur between non-metal atoms and allow for the formation of complex molecular structures. Single covalent bonds are formed when atoms share one pair of electrons, meaning that they have two electrons. This is represented by a single line, meaning that both atoms achieve a stable electron configuration. A double covalent bond is formed when atoms share two pairs of electrons, meaning that there are 4 electrons in total, and this is represented by a double line. A triple covalent bond is formed when atoms share 3 pairs of electrons, totaling 6 electrons in all. This is represented by a triple line, as shown. Dot and cross diagrams are visual tools that are used to represent the sharing and unsharing of electrons in covalent bonds. Each dot and cross represents electrons from the different atoms, and the bonds are shown as pairs of electrons in overlapping regions. In this dot and cross diagram, it shows 2 chlorine atoms sharing a single pair of electrons. Chlorine is a diatomic molecule, meaning 2 chlorine atoms share a single pair of electrons to achieve stability. Each chlorine atom has 7 valence electrons, meaning they are in group 17, and they share 1 pair of electrons to achieve a stable octet. It forms a single covalent bond, with both atoms achieving a full outer shell of 8 electrons. This dot and cross diagram shows a carbon atom forming 2 double bonds with 2 oxygen atoms. It consists of 1 carbon atom bonded with 2 oxygen atoms, which means it's a double covalent bond. Carbon has 4 valence electrons, which means it's in group 14, and each oxygen has 6 electrons, meaning they are in group 16. The carbon shares 2 pairs of electrons with each oxygen atom, forming 2 double bonds. This means that each atom achieves a full outer shell, with carbon having 8 electrons and oxygen having 8 electrons. This dot and cross diagram of ammonia consists of 1 nitrogen atom bonded to 3 hydrogen atoms using single covalent bonds. Each nitrogen atom has 5 valence electrons, meaning it is in group 15, and hydrogen has 1, meaning it is in group 1. Nitrogen shares 1 electron with each hydrogen, creating 3 single bonds, and nitrogen will retain a lone pair, which influences its molecular shape. In this dot and cross diagram, it shows a carbon atom forming 4 single covalent bonds with 4 hydrogen atoms. Each carbon atom has 4 valence electrons, which means it's in group 14, and each hydrogen has 1 electron, meaning it is in group 1. Each carbon atom is shared with each hydrogen to form a stable octet, creating 4 single covalent bonds, and this ensures each atom achieves stability, with 2 electrons in the outer shell for the hydrogen atom. To conclude, ions and ionic bonds help to explain how particles combine through charges and electron transfers. And covalent bonding shows and explains the sharing of electrons to enable stable configurations in molecules and polymer structures. And the knowledge of these bonding techniques found in atoms helps us to understand atmospheric chemistry and allows us to use this in synthetic applications. Thank you for your time.